Okay, before I leave, I think this might be the end of the lecture, I can't remember. Before we leave this discussion, let me talk about chemical leavening. So, yeast is a wonderful leavener, but it has some limited applicability. A lot of what we want to do in the kitchen is very quick. For example, muffins or pancakes. And so we need a leavening that's going to respond quickly. And this is probably a very simple idea to most of you. Uh, Acid plus base results in bubbles, carbon dioxide. So if you add baking soda to vinegar, there's your vinegar, acid, acetic acid, base, sodium bicarbonate. Add those together and you form the vigorous formation of carbon dioxide. That's your leavening. You're producing the same gas molecule that's going to be important for increasing the volume of your bread. There There are a variety of chemical leavenings, just like there are a variety of flours. This reaction is one just taken from your textbook. I think this is lactic acid plus potassium carbonate, again giving rise to CO2. That's the key ingredient here. Um, Something this brings to mind, though, is lactic acid. Where have we seen that before? Well, the lactic acid bacteria. Remember, they ferment carbohydrates eventually down to lactic acid. That So you can see that the acid that you can perform your leavening with can be derived from the food itself. So in this case, we use an natural, perhaps organic acid with some other chemical base, and we get our CO2. So let me restate that. That's important to remember as we move into other activities later this semester. We can use sodium bicarbonate or baking soda as our leavener, but we have to remember that we need to have some organic acid already present in the food in order to provide the sodium bicarbonate a partner to react with. That's going to be can be lactic acid. So if you see sodium bicarbonate or baking soda as your leavener in a recipe, also look for yogurt, right, or buttermilk, and that's going to provide you with the acid. Or you can use tartaric acid, um, and any or other organic acids as well. But oftentimes you'll be using an acid that's present in the food, and that's a quick reaction. So this is another thing that we worry about when we think about what kind of chemical leavening to use is where are the chemicals coming from, or do we have to add them, are they present already, what kind of reaction is that going to be, is it going to bubble immediately or is it going to happen over time, and depending on the kind of recipe that you're using, that can be very important. Your book mentions the fact that at a breakfast restaurant where they're serving breakfast from 7 a.m. to noon, they probably don't want to keep making pancake batter over and over and over. And so what they want to use is a leavening that's only going to begin to work once that pancake batter is poured onto the hot griddle. And so some of these we'll see happen slowly or quickly with the addition of heat. Now, of course, there are commercially available baking powders. Those provide the acid and the base together, and the most common of these is a combination of tartaric acid, cream of tartar, as the acid with sodium bicarbonate. That's your double acting baking powder. Double acting, really, this is telling us that it's some of the activity is coming from the mixing, so we're immediately begin to dissolve that tartaric acid and bicarbonate, and they react and form gas bubbles. And then some of that is only reacting after we begin cooking, and that's really just a matter of how soluble the two components are in the solvent that we're using, the recipe that we're using. These slowly acting baking powders, baking sodas really rely on the low solubility of the components, and then of course heat is going to improve the solubility of those components, and so that's why we can be heat activated. I want to mention again these acidic foods. Next week I'm going to give you a recipe to work on in which we use different chemical leavenings in making chocolate cupcakes or chocolate brownies or chocolate cakes. Um, Chocolate itself contains food acids, and these can interact with sodium bicarbonate and form, and that's where we get our leavening. But that reaction also changes the the color of the chocolate as well, and that's going to play an important role in an experiment that we'll see coming up. So stay tuned for that, and keep that in mind. Let's look at a few different kinds of breads and think about that texture again. I've mentioned this already, but it's worthwhile to reiterate it one more time. Cake's crumbly texture requires low gluten flour. Again, the flour that you use depends on the experience that you're trying to create. So low gluten means that that the network is not going to form, and you're going to have a poorly structured dough or batter, and that's going to give you a crumbly texture. Minimal mixing is also important in these. So many times you're going to see recipes where it calls for a few mixing the ingredients in a few quick strokes, and this is important for minimizing with whatever glutens happen to be present in your flour, minimizing the development of that network. So a few quick strokes is on one extreme, and kneading for 15 minutes is on the other extreme. And so that's going to be important to to maintain a nice texture in your quick breads. Mix quickly and minimally. Um, Blah blah blah. Frying batters, we'll come back to these again. Gluten is also important there. We create a clingy batter that sticks to our foods, but we also want to watch out because the same gluten can